1-5, Translating Graphs, Part 2, Reflections and Stretches. Alright, so now, there's two types of reflections of graphs. Okay, there's two types of reflections of graphs. The first type we're going to go over is vertical reflections, which is the reflection over the x-axis. So it's x-axis reflection. Alright, so here's an example. Let's look at an example. So here we have the simple square root graph. Alright, let's see, 1, 1. It's kind of off, but you get the point. So this is simply y equals the square root of x. Alright, that's our square root graph. Now, to reflect this over the x-axis, alright, to reflect this over the x-axis, this is what it's going to look like. Alright, let me draw in my axes. Now, to reflect it over the x-axis, it's going to keep the same shape, but now it's going to look like this. Same overall shape, just upside down. Alright, so this would be y equals the negative square root of x. Okay, so reflecting over the x-axis, it's just like you either put a mirror at the x-axis, so it literally reflects it over the x-axis, or you can consider it hinged on the x-axis, and all you did was turn it over the x-axis. So your graph turns upside down. Let's look at another example. Let's look at one that's been moved. Alright, so it's either got this one's going to have a vertical shift to it. Alright, it's going to be the square root graph, the absolute value graph, or at least as close to it as I can get. There's one, there's the other, and I was supposed to move that up one, and I didn't. Alright, so now this has been moved up one, okay? What would this look like reflected across the x-axis? Okay, what would this look like reflected across the x-axis? The equation is y equals the absolute value of x plus 1. Well, simple. It's really a simple answer. To reflect it across the x-axis, alright, it's going to look like this. Let me get my line tool back. Now, when you reflect it across the x-axis, it's going to simply look like this. Okay? So keep in mind, it's like we put a mirror at the x-axis. Okay, so this is -1 now. So it's like we put a mirror on the x-axis. Okay? So we completely flipped it across the x. Okay, so from here to here, it's a reflection across the x-axis. So now the equation for this graph would be y equals negative absolute value of x minus 1, or y equals negative parentheses the absolute value of x plus 1. Alright, so you can factor out the negative to get what the normal graph looks like, and then simply reflect it over the x-axis. Or if you want to go ahead and distribute that negative through, it would look like negative absolute value of x, which would turn it over, and then minus 1, which would pull it down. Alright, makes sense? Now, keep in mind, it does not look like this. This would be completely wrong. Alright, if you drew it like this, this would be completely wrong. Okay? Because the equation for this would be y equals negative absolute value of x plus 1. Alright, so that is completely wrong. Alright? So keep in mind, reflection over the x-axis, you have to distribute your negative through, so you either get negative absolute value of x minus 1, or you get negative parentheses absolute value of x plus 1. Alright, make sure you do not make this mistake. This is wrong. Alright. Now the next type of reflection is horizontal reflection. Horizontal reflection. And since the last one was reflection over the x-axis, of course this one is reflection over the y-axis. Alright, let's do some examples. Let's go back to our square root of x graph. Alright, if you remember, the square root of x looks something like so. Alright, this is y equals the square root of x. Now, to reflect this over the x-axis, the y-axis, you follow the same procedure you would do for the x, you're just flipping it over the y instead. Alright, so to reflect this completely over the y-axis, it's going to start here and go to the left. Again, it still holds the same shape, and overall it looks the same. It is just now reflected over the y, so it is physically pointing in the other direction. Alright, now what the graph of this would look like, and don't confuse this with the vertical reflection, this would be y equals the absolute value of negative x. Alright, y equals the absolute value of negative x. Alright, that's why it flips it around, because now positive numbers do not work in here. But if you put in negative x values, since negative times negative is positive, so it'll give you a value for all the negative x values, but not the positive. That's why it flips it around the axis. Alright, so that is a proper reflection across the y-axis. Okay? Let's look at a different graph. Let's look at one that actually crosses the y-axis and flip it. So y'all should all recognize this. If I'll give you a hint, that's 1. Alright, this is your y equals e raised to the x graph. So this is your exponential graph. Alright, let's reflect this guy across the y-axis. You know what? I'm going to make this the u try. So you try. Flip the y equals e to the x graph over the y-axis and write me the new equation. Alright. So let's draw in our axes. It's always the first part. So now, to flip this across the y-axis, alright, it's still going to go through y equals 1. Alright, it's still going to go through y equals 1. But now, instead of starting at the left, coming up through 1 and ending up high to the right, it's going to start on the right, come across, up through 1, this is completely terrible, and end facing up on the left. Alright? I know that's completely bad. Let me do that again. Let me try this again. Alright. I'm going to draw it reverse, but let's see. That's terrible too. Last time, I'm keeping whatever I come up with here. Alright, whatever. You get my drift. It should look the exact same as this right here. It should look the exact same, just flipped over the y-axis. Okay, it should look the exact same. So here we go, flip, flip, left, right. Haha, I don't know why I didn't do this in the first place. There we go, perfect. All right, let's get rid of this monstrosity. There we go. So that's what it should look like. All right. Now your equation would be y equals. Where would we put the negative? Would we do negative e raised to the x? No, we're not going to do negative e raised to the x because that would give us a vertical reflection. So we're going to do e to the negative x. All right. So just like horizontal shifts, your horizontal reflections need to affect your x values. Your vertical reflections affect the entire equation as a whole. All right. So let's do a quick summary. Just, so this makes it easier for you all to put in your notes because you should be taking good notes. All right. So a reflection in the x-axis or over the x-axis, which is a vertical reflection. All right. You put a negative, I'm bringing it in here, negative, your original equation. So your original equation, Q. All right. So reflection in the x-axis, it's negative parentheses your original equation. All right. So that negative is going to affect the whole equation. For a reflection in the y-axis, or horizontal reflection, all right, you change x into negative x. Change x into negative x. All right. So change x into negative x for a horizontal reflection. For vertical reflection, you do negative parentheses your equation. All right. Makes sense? Now, I can't finish this lesson off. I can't go into stretches without talking about order of operations, or PEMDAS. Order of operations. PEMDAS is really, really important for these guys. Okay? PEMDAS is, I'm going to write this part in red, important. All right, PEMDAS is really important. Let's do an example. So consider y equals the square root of negative x plus 2. Okay? Step 1. Okay, we're going to tackle this in 2 steps. Step 1. First, let's take care of y equals the square root of negative x. So let's take care of the negative x part first. It's an equal sign there. So let's take care of the negative x part first. So y equals negative square root of x is going to make this graph go this way, right? It's going to give it a y-axis reflection or a horizontal reflection because we changed x into negative x, all right? And the reason we did that first is because the m in PEMDAS comes before the addition, which is the plus 2, okay? So does that make sense? So why did we do the negative first? Because the negative is multiplication, and multiplication comes before addition in PEMDAS. All right. Then, so now step 2, we're going to take care of the horizontal translation, or the horizontal shift. All right. Now, I know a plus 2, you learned in last video, a plus 2 gives you a left shift. But in this case, since the graph has already been reflected across the y-axis, so we've turned everything around, all right? Since we've turned it all around, a positive now becomes a right shift, all right? But the only time a positive is a right shift, all right? So this is, 1, 2. The only time a positive is a right shift is when you first did a horizontal reflection. All right, because you can think about it as it flips the whole system. It turns it around. All right, we turn the whole thing around, so now it's backwards, so to speak. We turned our graph around backwards, so now the system is backwards. All right, so it has to be a right shift now because we've turned everything around. All right, make sure you make a note of this in your notes, that when you have a horizontal reflection, pluses now go right and negatives now go left. Okay? All right, now the last thing I want to go over is stretches. All right, let's go over stretches. No, it's not the kind you do before PE or before you play basketball with your friends. All right, so stretches. To stretch a graph wider, or squeeze it narrower, you're going to multiply the equation by a number. Oh, whoops. All right, we're going to multiply it by a number. Example. Let's look at y equals x squared. Y equals x squared is a nice parabola. How nice I'm going to draw is yet to be seen. All right, I missed the axis, but you know where it's supposed to go to. All right, so y equals x squared. Now, if we take and we multiply x by 2, all right, if we multiply x by 2, our graph is going to get skinnier, all right? Our graph is physically going to get skinnier. So our normal graph multiplied by 2. I really need to get better at drawing graphs on this thing. So now this is y equals 2x squared because we multiplied the graph by 2. All right. So it's the same graph. It's the same base graph. It's still y equals x squared, but now this one is more narrow. Okay, so in here, so there's less room between the two sides. All right, so this is narrower, or you can call it skinnier. Doesn't really matter what you call it. All right, it physically gets thinner. All right, it's like you grabbed the tops of them and you stretched them so they came together. All right. Now, to make this graph wider, all right, to make this graph wider or to stretch it out a bit, all right, let's see if you can figure it out. If we multiplied by 2 to make it skinnier, what do you think we're going to multiply by to get it wider? So let's widen this thing out pretty good. All right, so we're still working with y equals the square root of x. X squared. We're still working with y equals x squared, but now to make it wider, all right, to make it wider, there's not 2 D's in wider. I don't know why I did not. To make it wider, what did we have to do? All right, or we stretched it out. Stretched out. What did we have to do? Well, if we multiply by a number larger than 1, it makes it skinnier. If we multiply by a number between 0 and 1, it stretches it out. So this could be y equals 1/2 x squared. All right? Makes sense? Multiply it by a number larger than 1. All right, let's do, I'm going to write this down here for the summary. Make sure you have this in your notes. You'll need to remember this. So to squeeze a graph together, all right, you need to multiply by some number larger than 1. Okay, so in this case, we multiplied by 2 when we got it skinnier. So to squeeze a graph together, you need to multiply by a number larger than 1. Okay? To open a graph up wider, all right, you need to multiply by a number which is greater than 0 but less than 1. Okay, greater than 0 but less than 1. What do I mean? A proper fraction. Proper being the key term. The numerator has to be less than the denominator. If it's greater, then your number is greater than 1, so you're squeezing it together rather than opening it up. All right?